Okay, so this lesson is about the converse of Pythagorean theorem. And basically the converse of Pythagorean theorem says that we know that the Pythagorean theorem is a squared plus b squared equals c squared. Well, the converse says that if a squared plus b squared does not equal c squared, then it's not a right triangle. Then it's not a right triangle. Essentially, what the converse says. If a squared plus b squared equals c squared, then it is a right triangle. And if they don't equal, then it's not a right triangle. All right, so what we're going to learn is also that if they don't equal, then it could be an acute triangle or it could be an obtuse triangle. So those are three types we have. It could be acute, obtuse, or right. So if they don't equal, we're going to learn that how to recognize when it's acute and how to recognize when it's obtuse. So let's get started. The first example is this. It says verify that these are right triangles. So if this was a right triangle, then a squared plus b squared has to equal c squared. And I don't really know which one of these is c squared. I just know that if this is 8 and it's bigger than 7, so it might be the hypotenuse. Because the hypotenuse has to be the longest one. But that's the square root of 13. I know that 10 squared is 100 and 11 squared is 121. So I know it's somewhere between 10 and 11. So I know this number is bigger than 8. So I know if this was a right triangle, then this would be the hypotenuse. So the steps of proving would be basically take this would be C, this would be A, this would be B. So in short, if you wrote up that A squared plus B squared has to equal to C squared, then you would write 8 to the second plus 7 to the second will equal to the square root of 113 to the second. So 8 to the second is 64, 7 to the second is 49, and the square root of 113 to the second is 113. If you add up 64 plus 49, if this is the right triangle, then they will add to be 113. So let's add them. 64 plus 49. It does give you 113. So I know that this side is 113. The other side is 113. So that is a right triangle. This is a right triangle. Because a squared plus b squared equals to c squared. And I can check that out for other triangles. Like, here's an example where they squared a number of times a radical, 4 square root of 95, and they use that as a c. So they put c on this side and a squared b squared on the other. If you square that, this means you square the 4 and square root of 95. So it would be 16 times 95. If you do the math for it, that is 1520. And then 15 squared plus 36 squared, you add all that up, you get 1521. So since 1520 is not the same thing as 1521, this is not a right triangle. All right, it's not a right triangle. Let's talk about what kind of triangle this is, though. What we know for certain is that if, zoom in a little bit here. All right, what we know for certain is if the square of the length of the longest side of a triangle is less than the sum of the squares of the lengths of the other two sides, then the triangle is acute. Basically saying that if c squared is smaller than a squared plus b squared, then that triangle is acute. That's a theorem. There's another theorem that says if a triangle, if the square of the length of the longest side of a triangle is greater than the sum of the squares of the lengths of the other two sides, then the triangle is obtuse. That basically means that if c squared is larger than or greater than a squared plus b squared, then it's obtuse. Those are two important Theorem said no. So you don't have to know, you don't have to write down theorem 9.6 whatever, but these are two important theorems to know. Again, this is simplified. If c squared is smaller than a squared plus b squared, is acute. And if c squared is bigger than a squared plus b squared, then it's obtuse. So that's our other half we're going to check out now. So it says determine whether the sets of numbers can represent the side lengths of a triangle. If they can, classify the triangle as right, acute, and obtuse. All right, well, first of all, there's a theorem that says if these were sides of a triangle, then the two smaller ones have to be bigger than the third side. And 38 and 77 are smaller than 86. So if you add them up, they're going to be over 100. So they do add up to be bigger than the third side. So that's a right triangle. That's a triangle. And if you look at this, the two smaller sides are these two. And if you add up 10.5 and 36.5, that adds up to be about 47. And that adds up to be larger than the third side. So this also constitutes a triangle. So that's just the basics of being a triangle. You couldn't have two sides that were they don't add up to be bigger than the third side. So this side would say 2, this side would say 3. This side could not be, say, 7. In that case, it couldn't be a triangle because it wouldn't really close properly. So these two sides must add up to be bigger than this side. So the biggest that side could be is like 4.9. It was like 4.9, it would work, or 4.99. Anything bigger, less smaller than 5 would be okay. All right, so anyway, basically it says classify whether or not this is right, acute, or obtuse. So if we check this out, so this would be A, this would be B, this would be C. So this is a triangle. If it's a right triangle, then A squared plus B squared would equal to C squared. So 38 to the second plus 77 to the second would have to be bigger than 86 to the second. And just using my calculator, 38 to the second plus 77 to the second is 73. And let's see how that compares to 86 to the second. So 86 to the second is 73.96. 73.96. So they are not equal to each other. They're not the same. But 73.96 is bigger than 73.73. So in this case, C squared is larger. C squared is larger than A squared plus B squared. So the theorem says that if C squared is larger than A squared plus B squared, this is obtuse. So no, this triangle has to be obtuse. And we can check that out for other triangles, but I think you get the drift. This is how it works. You test to see if A squared plus B squared equals C squared. If they don't equal, you decide whether or not that triangle is acute or obtuse. That's all I have. Good luck.